The power rule. If n is a rational number, so n has a form like a over b, then f of x equals x to the n is differentiable, and d dx of x to the n is equal to n times x to the n minus 1. Now, we saw that. Remember when we took f of x equals x squared, we used the limit definition, so we took the limit as delta x goes to 0 of f of x plus delta x minus f of x over delta x. That was equal to the limit as delta x goes to 0 of x plus delta x squared minus x squared over delta x. That's equal to the limit as delta x goes to 0 of x squared plus 2x delta x plus delta x squared minus x squared over delta x. I just expanded this. And see my x squares go away. And then delta x will cancel with one of these, and will cancel with this one. So this equals the limit as delta x goes to 0 of 2x plus delta x. Now I can take this limit, let delta x go to 0, and that gives me 2x. Well, based on the power rule, in this case, if I have f of x equals x squared, then n equals 2. So the derivative of this, I'm going to take this 2, bring it down in front, and then subtract 1. So I'm going to end up with f prime of x equals 2x to the 2 minus 1. That's 2x to the first. That's just 2x. I'm not sure about you, but I'm thinking this is so much easier than saying, well, f prime of x is equal to the limit and doing all of that. So let's go ahead and apply the power rule to a couple of them. If f of x equals x to the fifth, then d dx of x to the fifth equals, I'm going to bring that 5 down, 5x to the 5 minus 1. That's the power rule, because in this case n happens to be equal to 5. So it's n times x to the n minus 1, which is 5x to the fourth. Now here, in order to take this derivative, I need to write this as a rational number, or at least this exponent. So I'm going to write this as, I want d dx of x to the 1/2. I'm going to write this radical as a fractional exponent. So that's going to equal, bring this down, see now n equals 1/2. So this would be 1/2 x to the 1/2 minus 1, which equals 1/2 x to the negative 1/2, which equals 1 over 2 times the square root of x. Now, we did the limit definition for this one. Actually, I think we did the limit definition for f of x equals the square root of x plus 1, I believe, some time back. And when we did that, what we ended up with was 1 over 2 times the square root of x plus 1. Now, if there's some other constant in here, this is just a side note, I'm getting ahead of myself. If there's some, like if there's a 3 in here, this would be slightly different. It's not quite that simple. It just so happens that when it's a 1, it turns out to be the same thing. But the idea is the same way. And we'll look at this with what's known as a chain rule a little bit later and a general power rule. Okay, so this last one, 1 over x squared. Well, I need to write that in a slightly different form. So I'm going to say I want the derivative d dx of x to the negative 2. See, now this thing is written as a rational number, this thing being the exponent. So this would be equal to, bring this negative 2 up front. So it's negative 2 x to the negative 2 minus 1. So this would be negative 2 times x to the negative 3, which is simply negative 2 over x cubed. So that is the power rule. Very, very, very powerful. I have something in the form of x to the n, then d dx of x to the n equals n times x to the n minus 1.